Hello everyone, myself Ankur Patel, and today in this session of engineering curves, we are going to discuss cycloidal curves. So today in cycloidal curves, we will discuss cycloid and types of the cycloid, which are known as inferior tropoid and superior tropoid. Well, epicycloid and hypocycloid are also the types of the cycloidal curves that we will discuss in our next lecture. So let's start with the cycloid. So what is cycloid? So it is a locus of a point on the circumference of the rolling circle, which is known as generator, which rolls without slipping or sliding along a fixed or straight line, which is known as the director. Let us understand by this animation. So if the circle rolls on a straight line path without slipping or sliding, then the curve traced out by a point which is on the circumference of the rolling circle is cycloid. So here in this figure you can see that how the cycloid is generated. So let's start with the problem of the cycloid. So the given content is a wheel or circle of diameter 50 mm rolls over a straight line for one rotation. Draw the path traced out by point P, which is initially at the point of contact between the wheel and the straight line. Draw normal and tangent at any point on the curve. So the given data is diameter of the circle is 50 mm. So the radius will be equal to 25 mm, and the circle is rolling for one rotation. That means the length of the straight line path or the distance covered by the circle on the straight line path will be equal to 2 pi r, which is equal to the circumference of the circle, and it will be equal to 157 mm. Now, first of all, draw a circle having radius is equal to 25 mm. Here we have shown the horizontal and the vertical diameter of the circle. So from the bottom of the vertical diameter, from this point, draw a straight line which is known as director having length equal to 2 pi r. Give the name as AB. After drawing the line, divide the circle into 8 equal number of divisions. So divide the circle into 8 equal parts. Now as we have divided the circle into 8 equal parts, we have to divide line AB into 8 equal number of divisions also. So divide this line into 8 equal number of divisions, give the numbering starting from here 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now after dividing the line and giving the numbering on the line, the circle is going to be rolled in the clockwise direction on this path. So the first division of the circle which is going to touch or which is going to be in contact to the straight line path will be this point. So start the numbering from here 1, 2, 3, 4, 5, 6, 7 and 8 in anti-clockwise direction. After giving the numbering on the circle, now draw lines parallel to line AB or parallel to the director from 1, 2, 3, 4. The lines from 1, 2, 3 will also pass from 5, 6 and 7. Now after drawing these lines from these divisions of the line 1, 2, 3, 4, 5, 6, 7, 8, draw lines perpendicular to line AB to get the intersection at the center line. So draw lines perpendicular to line AB to get the intersection at the center line. So this will be our C0, C1, C2, C3, C4, C5, C6, C7 and C8. These are the centers of the circle. Now after showing the centers of the circle, measure the radius of the circle on the rounder or measure the arc length of 25 mm, which is the radius of the circle on the rounder. Take C1 as center or take C0 as center and give an arc on the 0 line. So here we will get P0. Now having radius equal to the radius of the circle or equal to 25 mm and center at C1, give an arc on the line passing from the first point of the or first division of the circle. So from C1 give an arc over here having radius is equal to 25 mm. Now put your rounder or take the center as C2 and give an arc on the line passing from the second point of the circle over here. Put your rounder on C3 or take C3 as the center and give an arc on the line passing from the third point of the circle. We will get the intersection over here. Now put your rounder over here or take the center at C4 and give an arc on the line passing from the fourth point of the circle. So over here you have to give the arcs in the clockwise manner because the circle is rolling in the clockwise direction. Now take C5 as the center, radius is equal to the radius of the circle, and give an arc on the line passing from the fifth point of the circle over here. Now take center at C6, radius is equal to the radius of the rolling circle, and give an arc on the line passing from the sixth point of the circle. Now take center at C7, give an arc on the line passing from the seventh point of the circle over here, and from C8 as the center, give an arc over here. You will get the point at exactly 8. Now mark these points P1, P2, P3, P4, P5, P6, P7, and at B it will be our PA. Now draw a freehand curve passing through these points. That means from P0, P1, P2, P3, P4, P5, P6, P7, P8. Draw freehand curve. That freehand curve will be our cycloid. Now next is we have to draw a normal and tangent at any point on the curve. So first of all we have to mark that point on the curve. So let us mark that point S over here. Now from point S we have to give an arc, or by taking S as a center, we have to give an arc on the center line, and the radius of the arc will be equal to the radius of the circle. So taking S as a center, give an arc on the center, having radius is equal to the radius of the circle, which is equal to 25 mm. So this will be our T point. Now from point T, draw a line perpendicular to the director like this. This will be our S1 point. Now connect S1 to S will be our normal, and the line perpendicular to the normal and passing from point S will be the tangent. Now let's move on to next problem, which is inferior trochoid. So what is inferior trochoid? It is a locus of point P, which is inside the circumference of the rolling circle, which is known as generator, which rolls without slipping or sliding along a fixed or straight line, which is known as director. So here in this video you can see that if the point is inside the circumference of the rolling circle, then the curve traced out will be the inferior trochoid. So let's start with the example. Draw a locus of a point 20 mm away from the center of a circle which rolls on a straight line path. Take diameter of the circle is equal to 50 mm. So here the diameter or radius of the circle is given. So diameter is 50 mm. That means the radius of the circle will be equal to 25 mm, and the length of the straight line path will be equal to 2 pi r, or we can also say that the length of the director will be equal to 2 pi r, which is equal to 157 mm. So now first of all draw a circle having radius equal to 25 mm. Here we have shown the vertical, here we have shown the horizontal and the vertical diameter of the circle. So from this point, intersection point of the vertical diameter and the circle, from this point show the straight line path having length equal to 2 pi r. This is our director, and the length of the director is 157 mm. Now we have to draw locus of a point which is 20 mm away from the center of the circle. So first of all we have to mark this point which is 20 mm away from the center of the circle. So from the center of the circle mark point P0, which is 20 mm away from the center. So this will be our C0 center. Now after marking this point, take C0 as a center and radius equal to C0 to P0, or radius is equal to 20 mm. Draw a circle. This is the inferior circle, and the radius of the inferior circle will be equal to 20 mm. So after drawing the circle, divide this circle into 8 equal parts. Now, as we have divided the circle into 8 equal parts, we have to divide the straight line path, or we have to divide the director line AB into 8 equal parts also. So divide this line into 8 equal parts: 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, as the circle is going to be rolled in the clockwise direction, the first point will be this. So give the numbering on this inferior circle in anti-clockwise manner, starting from 0 over here: 0, 1, 2, 3, 4, 5, 6, 7, and 8. After marking the points on the inferior circle, now draw lines parallel to the line of the director from the points of the inferior circle. So from 1, 2, 3, 4, 5, 6, 7, draw lines parallel to the line of the director, starting from 0, 1, 2, 3, 4. After drawing these lines, now from these points 1, 2, 3, 4, 5, 6, 7, 8, draw lines perpendicular to the line of the director and to get the intersection at the center line. So draw the lines 3, 4, 5, 6, 7, 8, which should be perpendicular to the line of the director, and mark the intersection points. This will be C0, C1, C2, C3, C4, C5, C6, C7, C8, which are the centers of the rolling circle. Now, after marking these points, this will be our P0. Measure the radius of the inferior circle, which is equal to 20 mm. Take the center at C1 and give an arc on the line passing from the first point of the first division of the circle. So give an arc over here. Now take center at C2, give an arc on the line passing from the second division of the circle, and radius will be equal to the radius of the inferior circle. So we will get the intersection over here. Now from C3 as a center, give an arc on the line passing from the third point of the circle. Make sure that the radius will remain same for each arc, which is equal to the radius of the inferior circle, and which is right now 20 mm. Now take center at C4 and give an arc on the line passing from the fourth division of the circle. Take C5 as the center, give an arc on the line passing from the fifth division of the circle. Take center at C6, give an arc on the line passing from the sixth division of the circle. Take center at C7 and give an arc on the line passing from the seventh division of the circle. And from C8 we will get the point over here, exactly over here. So mark these points. This is P0, this is P1, P2, P3, P4, P5, P6. This will be P7, and P8 will be over here. Now draw the freehand curve passing through these points P0, P1, P2, P3, P4, P5, P6, P7, P8. We will get the inferior trochoid. Now let's move on to next, superior trochoid. So what is superior trochoid? So it is a locus of a point P which is outside of the circumference of the rolling circle, which rolls without slipping or sliding along a fixed straight line, which is known as director. So here in this video you can see that if a circle rolls on a straight line path without slipping or sliding, then the curve traced out by the point which is outside the circumference of the rolling circle is known as superior trochoid. So let's take the example. Draw a locus of a point 30 mm away from the center of a circle, which is known as rolling circle also, which rolls on a straight line path. Here we will again take the rotation of the circle for one revolution or one rotation of the circle. Take diameter of the circle is 50 mm. So the given data is radius of the circle is 25 mm because the diameter is 50 mm. And here we are going to take the rotation, or we are going to take one rotation of the circle. So the length of the director will be equal to 2 pi r, which is equal to 157 mm again. And we have to draw a locus of a point which is 30 mm away from the center of the rolling circle. So first of all, draw the rolling circle having radius is equal to 25 mm. and here we have shown the vertical and horizontal diameter of the circle. So from the intersection point of the vertical diameter from over here, draw a detector line which should be perpendicular to this line and having length equal to 2 pi r, which is equal to 157 mm. Now after drawing this line, we have to mark this point which is 30 mm away from the center of the rolling circle. So mark this point which is 30 mm away from the center of the center C0 of the rolling circle, and which is outside the circle or outside the rolling circle. So we will get the superior trochoid because the point is outside the rolling circle. Now C0 as the center and radius is equal to C0 to P0, which is equal to 30 mm. Draw another circle which is known as superior circle, and the radius of the superior circle will be equal to 30 mm. Now after drawing this circle, divide the circle into 8 equal parts. So after dividing this circle into 8 equal parts, we have to divide this detector into 8 equal parts. So divide this detector into 8 equal parts. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now again the circle is going to roll in the clockwise direction. We have to give the numbering on the superior circle in the anti-clockwise manner, starting from P0 over here. 0, 1, 2, 3, 4, 5, 6, 7, 8. After giving the numbering on the superior circle, now we have to draw lines parallel to the line of the detector from the points of the superior circle. So draw lines parallel to the detector from 0, 1, 2, 3, 4. And as we know that the line from 1 will also pass from 7, the line from 2 will also pass from 6, the line from 3 will also pass from 5. So after drawing these lines from the points of the detector 1, 2, 3, 4, 5, 6, 7, 8, draw lines perpendicular to the line of the detector to get the intersection at the center line. So draw lines perpendicular to the line of the detector from each point and mark the intersection point. This is C0, this will be C1, C2, C3, C4, C5, C6, C7, C8. Now after marking these points, measure the arc length of 30 mm, which is equal to the radius of the superior circle, and take center at C1 and give an arc on the line passing from the first point of the circle. So give an arc. Now take center at C2 and radius is equal to the radius of the superior circle, and give an arc on the line passing from the second division of the superior circle. So give an arc over here, you will get the intersection over here. Now take the center at C3, give an arc on the line passing from the third division of the circle. So we will get the intersection over here. Now radius is equal to the radius of the superior circle, and center at C4, give an arc on the line passing from the fourth division of the circle. Continue to give the arcs by taking center at C5, give an arc on the line passing from the fifth division of the circle. Take center at C6, give an arc on the line passing from the sixth division of the circle. Take center at C7, give an arc on the line passing from the seventh division of the circle, and C8 at the center and give an arc on the line passing from the 8th division of the circle. So we will get the intersection over here, exactly over here. Now mark these points P0, P1, P2, P3, P4, P5, P6, P7 and P8, and draw the freehand curve passing through these points. This curve is known as the superior trochoid. So this is it for today. Thank you for watching. We will discuss epicycloid and hypocycloid in our next lecture. Till then, take care.